Hello everyone, hope you all are doing well. So, today we are going to discuss topic 13D of weed science. The continuation of previous topics. We have done 13A, B, C of weed science. So, today we are going to deal with topic 13D. So, what we are going to deal today is about herbicides. Herbicides or weedicides. So what are herbicides? I hope you all know it. You all been learning it from in previous classes. That what is herbicide? It is chemicals used to kill weeds or other plants. We all know that weeds are also plants. So these are chemicals which used to kill weeds. That is what weedicides or herbicides is. So moving on to its classification. Classification of herbicides. First of all, there is based on chemical structure. Based on chemical structure. Based on chemical structure, we have got two types. First of all, we have inorganic, and second is organic. Inorganic are those which do not contain carbon atoms in their molecules. Do not contain not contain carbon atoms in their molecules. So these are inorganic. For example of inorganic, we can give off sodium arsenate, we have got sodium chlorate, sodium arsenate, sodium chlorate, we have got borax, we have got CuSO4, we have got copper nitrate, sorry, I am adjusting here, but I hope you all understand this. So this is what inorganic herbicides are, that do not contain carbon atoms in their molecules. Now moving on to organic herbicides, these are those organic herbicides. These are those which contain carbon atom in their molecules. So example of organic herbicides are wild type, example diesel, we've got xylene, we have got other aromatic oils such as polycyclic aromatic oils. So these are some of the common examples of organic herbicides. So hope you understand the difference between inorganic herbicides and organic herbicides. And these are based on chemical structure. These are some of the common examples. Hope you get this. Now moving on. To based on second method, that is based on selectivity. Based on selectivity, we have got number one, selective herbicides. They kill only targeted weeds. Kill only targeted weeds. Suppose we are targeting a weed, for example Phalaris manner. So when we will apply these selective herbicides, these herbicides will kill only Phalaris manner. Hope you all understood it. Some of the common examples of selective herbicides are atrazine, simazine, 2,4-D, pendimethalin, alachlor, etc. So these are some of the common examples of selective herbicides. Now move on to non-selective. Instead of killing targeted weeds, which you see in selective, in non-selective they kill all vegetation. Kill all vegetation. Suppose in a field there are 5 types of weeds, 2 types of other vegetation, other crops. When you apply these non-selective herbicides, they will kill all the vegetation present in the field. Example, we have got paraquat, we have got diquat, glyphosate, etc. So these are some common examples of non-selective herbicides, and usually you will see that especially here the non-selective herbicides, as they kill all vegetation, they are applied before sowing of crops, so that all the weeds and vegetation are killed in the field and crops doesn't get affected as they are not sown yet. Now moving on to another classification, that is based on translocation. Based on translocation. Here number one we have got systemic. That is, they move within the plant. Move within the plant or inside the plant. For example, we have got atrazine, simazine, we have got propanil, 2,4-D, etc. So these are some common systemic herbicides. Now moving on to contact herbicides. They kill plant when they come in contact with the plant. They come in contact with the plant. Example we can see here, we have got paraquat, diquat. So here you will also see a trend that all the many selective herbicides are systemic and many non-selective are contact. Non-selective are mainly contact and selective are mainly systemic. Now moving on to time of application. Based on time of application, this is the fourth criteria, or criteria number D. Based on time of application, when we apply those herbicides. Number one, we have got pre-plant stage, that is before planting. Here's some common examples: alachlor, we have got fluchloralin, FLUCHLORALIN, etc. Now here comes pre-emergence herbicides. Here we apply herbicides before the emergence of weeds, but after emergence of crops. So in this we see that crops have emerged but weeds are not emerged yet. So we will apply pre-emergence herbicides. Example, all selective herbicides, they are trazine, simazine, are pre-emergence herbicides. Now moving on to post-emergence. After emergence of both weed and crop. After emergence of both, some common examples are 2,4-D, propanil, diquat, paraquat, etc. So these are some of the common examples of, these are the types of herbicides. I hope you all understand it. Now moving on, factors of herbicide selectivity. What are the common factors of herbicide selectivity? So we'll give the title here. Factors of herbicide selectivity. How herbicides select some certain weeds and not other crops. There are some reasons. First of all is differential rate of absorption. So here, due to difference in morphology and growth habits of crop and weeds, herbicides is applied. So as you know, difference in growth morphology of crop and weeds, both have different growth morphology, and here we can use differential rate of absorption. For example, we can see 2,4-D is more fastly absorbed by weeds, hence they are killed as compared to crops. So when you apply 2,4-D, the crops, their morphology is different, but 2,4-D attacks the weed morphology, which helps them to absorb fast. The weeds absorb 2,4-D fastly and they get killed. Now moving on to second point, that is differential rate of translocation. Differential rate of translocation. As you know, herbicides translocate faster in weeds. Moving on to third point, that is differential rate of deactivation. This is the third point, that is differential rate of deactivations. That is crops deactivate herbicide due to herbicides due to use of metabolism, reverse metabolism, and conjugation. So crops deactivate herbicide. The effect of herbicides cannot seen in crops because the use of metabolism, reverse metabolism, and conjugation of the crops. Now moving on to the next point, that is differential rate of protoplasmic resistance. What happens here? Herbicides make deficiencies of certain vitamins and amino acids in targeted weeds. That is, herbicides make deficiency of certain vitamins and amino acids in targeted weeds. So what happens? The weed certainly in some time gets killed. Now moving on to the next point, that is, sorry, these were the four factors of herbicide selectivity. And one question was asked in previous years, the selective herbicide of rice and wheat. So we will discuss here selective herbicide of number 1, rice. The major weeds of rice are Echinocloa, Echinochloa, Echinocolona, and Phalaris minor. These two are the some major weeds of rice. So which selective herbicides we will use here? First of all, we will use Butachlor after 3 to 6 days after sowing. DAS means days after sowing. We can use pendimethalin 3 to 7 days after sowing. We can use pretilachlor, PRETILACHLOR, pretilachlor 3 to 7 days after sowing. Now one more crop is that is of wheat. It's common weed. We all know that common weeds of wheat is Phalaris minor, Poa annua, Avena, Ludovicinia. So these are some of the common weeds of herbicides and the common weeds of wheat. And the selective herbicides we will use it pendimethalin 0 to 3 days after sowing. We can use 2,4-D, second weedicide, selective weedicides we can use, and selective herbicides we can use for 30 to 35 days after sowing. Then we can use metsulfuron methyl after 30 to 35 days after sowing. We can also use one more herbicide, that is chlorsulfuron, chlorine plus sulfur, chlorsulfuron after this also 30 to 35 days after sowing. So these are the some of common selective herbicides of rice and wheat. I hope you all understand it. Now moving on to the next topic, that is mode of herbicidal actions. How herbicide acts, mode of herbicidal actions. First of all, that is growth regulators. They regulate the growth of weeds. Retard the growth of plants or weeds. For example, we can give here 2,4-D or MCPA. These are growth regulators. We have got photosynthesis inhibitors. What they do? They block the light reaction of photosynthesis. Block the reaction of photosynthesis. Example of photosynthesis inhibitors are atrazine, metribuzin, etc. When there will be no photosynthesis, how can weeds grow? So these are photosynthesis inhibitors. We have got amino acid inhibitors. They inhibit or retard the protein metabolism and nucleic acid metabolism. Examples of amino acid inhibitors are glyphosate. We have got sulfonyl urease, etc. These are some of common amino acid inhibitors. Now moving on. We have got lipid synthesis inhibitors. Lipid synthesis inhibitors. They prevent formation of fatty acids, and we all know that fatty acid synthesizes lipid. So when there will be no formation of fatty acids, how lipid can be synthesized, and that can lead to retard the growth of weeds and lead to its death. Examples of lipid synthesis inhibitors are cethoxidine and quizalofop. These are some common examples of lipid synthesis inhibitors. We have got seedling growth inhibitors. They inhibit the growth of seedling of weeds. So what happens here? The new plant cannot grow as the seedling cannot grow. So no growth, no development. So the weed will never grow. Example we can give here is pendimethalin, trifluralin, etc. Trifluralin. And moving on to pigment inhibitors. They prevent the plants from forming photosynthetic pigment. Inhibit the formation of photosynthetic pigments. Some common examples are clomazone, peridaziones, and last we have got cell membrane disruptors. They are usually post-emergence contact herbicides. And they disrupt the cell membranes, hence leading to the plant death. Examples are paraquat, difenoquat. So these are some of the common examples of cell membrane disruptors. So this is how herbicidal actions occur. These were the mode of herbicidal actions. Hope you all understand it. Nothing rocket science in it. Keep making notes, that will help. Keep making notes, keep revising notes, and that is your Brahmastra. Notes are the key to success. The questions in the exam will be from notes, and the way examples, you need to remember the examples. When you write examples in your answers, that will certainly enhance your marks. Now to the last topic of today's lecture, that is advances in chemical weed management. So we are using chemical weed from just after Green Revolution only. We are using a high amount of chemical weed, but we have made certain advances in recent times. It was asked in previous years, that is why I am dealing here. So what are those advances? First of all, proper dosing of herbicides. We are just not applying herbicides in the field without proper dosing, but dosing how much is required, what is the quantity of weeds there, what quantity is properly required, so that the excessive use can be regulated. We are doing herbigation. What herbigation is? Herbicides through irrigation. Herbicide through irrigation. I hope I have taught about fertigation in previous lecture. This is herbigation. In fertigation, fertilizers through irrigation. It is commonly used in drip irrigation. What we do in the tank of drip irrigation, we add a certain amount of herbicides, which through irrigation in the field control the weeds. We have developed some herbicides, development of with less resistance. Herbicide resistance has been a common problem, that the weeds which were being previously killed by that same herbicide is not being killed by that herbicide. The herbicide that used to kill the weed in previous times are not affecting the weeds right now. So what happens, the weed creates a resistance of these herbicides. So we are developing herbicides with less resistance so that weeds can't create resistance. We have enhanced proper weed management to enhance efficiency of chemical herbicides. We are using technologies avoiding wastage of weeds. To avoid wastage, for example, you can give here one technology is sprayers. Sprayers of proper technology. So what these sprayers do, they spray a certain amount which is required in reducing the wastages. Now moving on, we have started use of remote sensing in herbicide application and weed management. So remote sensing helps to counter the weeds, where the weeds are present, at what amounts, how much weedicides or herbicides we require. So we are using remote sensing now. Allopathy interaction. Studying hardly on allopathy interaction with chemical weed management. Allopathy, interaction between plants. When plants release certain type of chemicals which affects other plants. So these allopathy has been now hardly used in chemical weed management. We are researching here that the chemicals developed by crops can kill the weeds. So research on allopathy. We have got some intelligent weed control techs. Intelligent weed control technologies we are using in recent times. For example, sensors, or we can say weed sensors. With herbicide sprayers, the herbicide sprayer through the sensor can get the amount of herbicide required to kill that weed. So only that amount is sprayed. We are now using weed scales. First we do scaling of weeds, then we fix the dose and then apply in certain parts of field now, so that the weed is killed without excessive use of weedicides or herbicides. Proper control of leaching weeds. Leaching weeds, as when you use excessive amount leaching weedicides or herbicides, when you use excessive amount of herbicides, then those leach sometimes to groundwater, which affect our environment. So through proper efficiency, by managing proper efficiency, enhancing the weed management, we are using only that much amount of weed that is required to kill, that much amount of weedicide or herbicide that is required to kill the weed. So there will be more efficient use, and the leaching problem of leaching is controlled, hence protecting our environment. So these were some of the common advances in chemical weed management that we are making in recent times. So that's all for today. For any query, just comment. Please please press the like button if you like it, share and subscribe. That's all for today. Have a nice day. Thank you.